Hi, welcome to my presentation, Economic Relations. First, I'll present to you the research questions, followed by why I picked these questions, and then I'll show you the technological stack we use to get to the results. We'll show the initial results and how they were refined into observations that eventually answer our research questions. The primary research question is, do certain industries, as depicted by the price of their representative index, do better than others relative to interest rates and unemployment fluctuations? The secondary question include, which industries can you invest in to protect yourself from periods of high inflation, and which industries could you potentially invest in to hedge your bets against potential unemployment? I wanted to study complex adaptive systems because I wanted to solve harder problems, and the hardest problems typically involve people. If we're able to map out the behaviors of these people and how they affect outcomes, we're able to more objectively assess a situation. I want to be good at what we're learning. The topic of this class is especially relevant to the work we do at Fluke. It helps us make sense of complex data. I picked these research questions because the economy seems to be unpredictable. I wanted to provide a sort of sort of a possibility of a tool to help us navigate this economy. I'm also personally interested in how these different industries are related as it pertains to macroeconomic indicators. This is my tech stack. First, we use the MSCI sub-industries resource to find all the sub-industries, and then we fed a prompt into Google's Gemini, US ETFs representing sub-industry here, and return a list separated by commas. And then from those ticker names, we pulled data from Yahoo Finance, which is pretty much the last 20 years starting back from March. And then I downloaded data from the USBOS and the treasuries and processed the data by calculating the returns by percentage. If the denominator was 0, I placed it by 1, which only really happened for interest rates. And I had multiple feeder matrices because there was very few tickers that had complete data from 20 years. There was about 50 of them, and there's about 200, almost 200 tickers that was complete in the last 4.5 years. I applied principal component analysis and TSNE. I would say we should disregard the initial results because what happened was the tickers with the highest prices dominated the variance, which makes a lot of sense. The absolute values distorted the results. However, you see something interesting how oil moves the other direction while the big tech stocks, the biggest companies are moving one, oil is moving in the other. And for reference, VGT stands for the Vanguard Information Technology Index, and the SPY stands for the S&P 500, the 500 largest companies by the U.S. The first feeder matrix included 20 years of full data. If there was any discontinuities with the ticker data, I just eliminated the ticker. For feeder matrix 2, I found that about 4.5 years meant a lot more tickers being included. This is how we refined the data to make sure to make it so our analysis makes a little more sense. First, we apply relative returns, which is the percentage change really from one time period to the next, and then we normalize those returns by subtracting them from the mean and dividing them by the standard deviation. And then finally, we used scale returns, which is the entry minus the minimum divided by the difference between the maximum and minimum entry for each of the columns. And we were able to invert the t-SNE, and now it's graphed with the tickers instead of time, which didn't really make sense in that context. And the we're also incorporating a correlation coefficient to try to help us answer the research questions. In this first visual, I wanted to show how we were able to retain more information for after the process of normalization. As you can see, the first component with absolute prices was able to explain almost 90% of the variance. However, when you go to the normal returns versus the scale returns, and what we're seeing that each time we process the data, it takes more principal components to explain the variance, which is a positive result because it means we're retaining information more effectively. And with the feeder matrix 2, which has 190 columns, we see that it takes 25 principal components to get to a 95% explanation for the variance. We find out that the scale normalization is more interesting than the normalization by standard deviation. As you can see, the weights from the principal component analysis are more varied and there's a more diversity of it. So for the rest of to process feeder matrix 2, we decided to go with the scaled representation, which is the golden standard for training machine learning models. It is proficient at retaining and normalizing information by keeping everything between 0 and 1. So this is the results of the scaled matrix for feeder matrix 1. We see these tech tickers taking the very top in terms of weight explained by the first principal component. On the other hand, we see things like unemployment, inflation, and risk-free interest rate on the end with a negative association on unemployment. So I would infer the first principal component to be related to economic strength. As we know, tech leads the economy. I think the second principal component, I'm interpreting it as discretionary spending, and this is by the fact that we have tech in the front again, and we have these utilities in the back. And and what we can apply from economics here is that utility spending is a lot more inelastic, as in you're going to spend money on it whether or not the economy is good. It's unlikely people will give up their hot showers, but it's likely for them to delay purchasing a newer smartphone if the economy is weak. This is the dot product of the first component scaled on the tickers. What you see is it's basically it's almost a normal distribution that has a left skew. And if you think about the nature of returns in the stock market, it makes quite a bit of sense. Most of the time it's positive, but sometimes you have these left-tailed events that happen occasionally. So this is the expanded analysis of the principal component. As it pertains to the tickers, we can see the heaviest weights are all related and industrial parts of the economy. What's disturbing about this is that it is in the same direction of unemployment, which is sort of indicating that these industries are able to appreciate in their equity by incorporating more AI and automation, which is a disturbing thought because if they're doing better because there are less jobs, that is not good. These are the parameters I used for the TSNE. You can find a higher quality version of it. I'm attaching it. What we notice are the clusters of inflation and unemployment in the same place. Meanwhile, the IDU, VPU, and PUI, which are utility indices, they're clustered on the other end. So, did we answer any of our research questions? Well, the answer is yes. Utilities are as supported by the first and second principal components of feeder matrix 1, we see that utilities are negatively associated with the directions of the principal components. They are known to have high dividends and to have inelastic demand in turbulent economic times. So in some ways, answering the main research question also answered 2 and 3, because according to the TS&E visual, we saw that high inflation and unemployment were grouped together. And on the other side of that grouping was utilities. When we add the analysis to also contain the heat map, we notice that oil has an inverse relationship with unemployment, which means if you short oil while being unemployed, that may help you financially if you do it right. This is not investment advice. So I wanted to have some questions that I could answer in your review and replies to this. Is technological and financial advancement actually bad for most Americans? If that is the case, and we could discuss this for a very long time, how could we instead design an economic system that protects people from inflation and unemployment? Also, I want to point out the solutions that I offered here are only available for people with money to invest in the market, which belongs to a privileged class of Americans that can understand this, assess this information, and act on it. These are my citations. Because I used previous code, I cited myself from CAS 502.